This is a lift-off box. To close it, you just put the lid on top of the bottom section and it grips it in such a manner so that it does not come off very easily. To open this, just pull it little upward and the lid comes off. These kind of boxes can be used for multiple purposes. This can be used for the small part storage. For instance, you can keep your tools, screws, nuts, bolts. You can use it for your electronics, keeping your wires or other electronic components. Or you can even create your personalized gift containers with the help of this pattern. In my opinion, this is the simplest box design which can be 3D printed without any additional customizations on the 3D printer side. And this is what we are going to learn, that how we can 3D print such a box. We will be doing this in two steps. First, we will be designing the 3D box components, and second, we will be 3D printing them. To design the box, we are at tinkercad.com. We will be creating the box in two steps. First, we will create the bottom section of the box, and second, we will create the lid of the box. To create both the bottom part as well as the lid, we will be using the basic shapes, which is available on the right hand side. The most common basic shape here is the cube, which is also referred as box. Let's pick this and bring it at the center. Let's size the length as 50 mm and width also as 50 mm. We will make this 20 mm tall. Please note that I'm choosing this smaller size to ensure a faster printing at my end and definitely to optimize on the filament consumption. But you can print this box in any size what your 3D printer allows as the maximum dimensions. Now that we have a solid box created, we need to create a space inside this box so that we can use it as a storage. For that, we will be using this hollow box. The only difference between this box and this box is that this is all solid, whereas this is all hollow. So let's bring this here. If we have to create a storage ensuring that there is a 2 mm width across all the different sides of this box, then we need to change the length and width of this hollow box accordingly. Which means if the length was 50 mm for the solid box, then this will be 46 mm because 2 mm from the left side and 2 mm from the right side will add together as 4 mm, and which we will reduce from the 50 mm total length. Similarly, the width also we will choose it as 46, and from the bottom let's leave 2 mm only, so the height will become 18 instead of 20. Now that we have the hollow part as well as the solid part, let's align these boxes. I'll select this and select this and click on the align button on the Tinkercad, and we will align this based on the solid box. So let's click on the solid box. From the length aspect, let's click on the center here, and the same thing we are going to do with the width perspective also. And then from the height perspective, we are going to stick it to the top so that the empty space starts from the top itself. And you can see a transparent space is now visible here. If you want to have a better view on this, we can combine these two items by clicking Union Group. And you can see the bottom part of the box storage is ready with us. A lid also needs to be created and designed in a similar fashion as we did the bottom part. But in this, we will start with the hollow part first. So let's bring that. The height of this should definitely be smaller than the bottom part. So I'm just keeping it as 5 mm. And what should be the length and what should be the width? This is the most tricky part here. Please note that the length and width of this hollow thing should be little larger than the outside dimension of this box. As the outside dimension is 50, so we are going to keep 50.2 mm as the length and 50.2 mm as the width, which means we are leaving zero point 0.1 mm on the left side and the 0.1 mm on the right side if we are looking from this side, and if we are looking from this perspective, then again the 0.1 mm from this and 0.1 mm from this side, which means along the periphery there is a tolerance of 0.1 mm, and this is going to help us the lid to be fitting exactly on top of this bottom part. Now that we are ready with the hollow part of the lid, let's bring the solid part. And the length of this is going to be bigger, of course, than the hollow part, which is 50.2. Again, we are ensuring the 2 mm across all the sides of it, which is very similar to what we did in this bottom part, and which makes it 54.2 and 54.2. The height of this box is 5, so we are again going to have 5 plus 2, which is 7 mm as the height of this solid part of the lid. Now let's align these two parts to make it a complete lid. Let's click on the solid one. Let's bring to the center and let's align this at the top so that we can see the transparent zone, and combine these two shapes and our lid is ready. With this, now our model is ready for the box. So let's go and export it. I'm going to click on the export and click on the STL, which is supported with my 3D printer. I'm calling the file as liftoffbox yt.stl and saving it here. Now we are at the Bamboo Studio. We are going to import the file which we just saved. So I'm at the prepare stage of our project. I will be importing a new file with this import, and I'm going to select the file which we just saved, and this is right here. I don't need to do anything extra. If you see, we are using the PLA basic filament, and rest of the settings remain as it is. If we go to the preview, it says the slice is okay, which means we are ready to print this. Let's click on print plate. It says the overall time for this box to be printed is going to be 38 minutes, 48 seconds, and this is going to be 28.78 grams. My Bambu Lab is already connected to the printer, so I can see that here. So now all the configuration is set. So let's go and click on send, and this will send the print job through the cloud service to this printer. These are the two parts which we designed. It's successfully printed. Let's see how it works. This is the bottom section and this is the top lid. If I put on top of the box, it completely grips the bottom section sufficient enough so that the lid is not coming off. So even if I'm moving around, putting upside down, nothing is happening with this. But if I'm putting a little pressure towards up, I am able to open the box. And this is what we were expecting. Please note that we have left a 0.1 mm gap across all the outside edge of this box to ensure that this fits on top of it, and at the same time if we want to remove it, we can be removed. This cap is based on the PLA filament which I am using, and the printer which I am using is the Bambu Labs A1 Mini. But if either of these things changes, this gap could vary, and you might need to do some iterations to figure out what is that exact gap which is not causing it to be very loose or it to be very tight. I also wanted to highlight that you will find a variation for lift off lid box pattern in the real world. For instance, this is the box which is very similar to ours, where the lid is bigger than the bottom section. But if you see this section or this particular box or this particular design, in these boxes, the length and width of the lid is very similar to the bottom section of the box. This becomes possible with the extended inner edge. Another variation is that you can have a knob on the top of the lid which can help you lift this box. You can also find this kind of additional help at the corner sometimes. And all these variations, they help you out in holding the lid and lifting it off the box. In spite of these variations, the fundamental remains same for this pattern. The lid has to snug fit on top of the bottom section of the box. With this, we are able to successfully 3D print a lift-off lid box pattern. We already saw in the video that how easy it is to design such boxes and 3D print them. I hope it helps all the DIYers to define your own custom storage solutions. You can find the links in the description for the design part of these parts as well as the dimensions of it.